All right, welcome to worksheet number 3, set operations and Venn diagram. That corresponds to textbook page 321. Last worksheet we talked about the concept of sets and how we use it to categorize or group different people into different groups. In the worksheet, we'll explore more complicated but more realistic sets by combining and relating different sets. For example, maybe a certain scholarship requires that you need to have at least 2.8 GPA and you need to have a major in health science or whatever. So here we're looking at two different set of people who have GPA 2.8 or higher, well at least 2.8, and people who major in health science. So it is more interesting or more realistic when we have multiple sets and we're trying to see how they interact or how they relate. So first concept we're going to talk about here is the intersection. Intersection of two sets A and B contains only elements that are in both sets. Symbolically, the intersection is written as A intersection with B. This is like upside down intersection. It's basically upside down U. The second concept is the union. Union of the two sets A and B contains all the elements. I'm going to underline all the elements in either A or B, or even both. So you could be in A, or you could be in B, or you could even be in both A and B. Symbolically, the union is written as A union B. It's basically U. So U is the union. So symbolically, U is the union. Upside down U is the intersection. Again, intersection is you have to be in both A and B. Union is you're in either A or in B or in both. So as you can see, it contains a lot of stuff. Symbolically, let's go back to intersection. A is in A and highlight and there. X is in B, then A is in A intersection B. For the union, if A is in A or highlight or A is in X is in B, then A is in A union B. Generally speaking, it's harder to be in A intersection B. It means A and B. So you have, like for our first example, you have to have a high GPA and you have to also major in health science. So not many elements will be in the intersection. So generally speaking, A intersection B is a smaller set. On the other hand, it's easier to be in A or B or A union B. So more elements will be there. So union becomes usually larger set. Let's look at some example. The Intersegmental General Education Transfer Curriculum, IGETC, is a series of courses that California Community College students can complete to satisfy freshman and sophomore level general education requirement before transferring to most colleges and majors at UC campuses. So you probably heard it before. If you're planning to transfer to Cal State, most Cal State we have a agreement. PCC has an agreement with Cal State, so you can take a bunch of classes here, and they kind of guarantee that you can transfer to their school. It has 6 subject areas of the requirement. There's a link here in your worksheet, so if you have a worksheet, you can click on it. You can get more information. Okay, so let's look at number 3. Area 1, the English communication requires IGETC says 6 semester unit must be completed prior to transfer, 1 course from 1A, and, so I'm going to underline, and 1 from 1B. So I'm looking at the people who did 1A, and I'm looking at people who did 1B. It says 1A and 1B, so I'm looking at the intersection, right? So let's say you have a universal set, A, Bethany, so on and so forth. You notice that it's A, B. I'm looking at like the first letter is A, B, C, D, E, F, G. So let A be people who passed 1A, and B be people who passed 1B. So let's get part A. It says write out A union B. Again, what was union again? The U thing means you can either be in A or in B or even in both. That means whoever take 1A, whoever take 1B, or even take both classes. So let's see. As I said before, union is easier to be union, so you're going to get more people in it. So A union B is, so basically when I find union, I'm just looking at A, basically write out every union in A. So Abe, Bethany, Carla, David. Bethany took A and B, so I don't have to rewrite Bethany again. David took 1B. Ellen is also included. Frank is also included. So Ellen is included here because she took 1B. Frank is included here because he took 1B, even though they didn't take 1A, which is fine. Let's look at a intersection B. So this is A and B. You have to be both in A and B. So basically, I'm looking at the set of people who took both 1A and 1B. So A intersection B. Again, before I even write out the answer, because this is intersection, it's hard to be in there. That means it's not going to have that many people. So who took both 1A and 1B? I notice not Abe, because Abe did not take 1B. Bethany, see, Bethany did. Carla, no, because Carla didn't take 1B. But David took 1B and 1A. So just B and D, that's it. So I'm sorry, let's go back to A. Describe in words what kind of people. So they either took 1A or 1B or even both. Here for part B, the intersection, they took both classes, both 1A and 1B. So according to the I get C requirement, they actually satisfy the condition. A complement intersection with B. So here I'm going to try to do it in 2 steps maybe. So I noticed that C from last section, this is complement, so whoever is not there. So it's whoever didn't take 1A. So A complement, let's look at that. A, B, C, D. So Ellen, Frank, Gina, Helena. So Ellen, Frank, Gina, and Helena. And I'm going to try to intersection that with set B, B, D, E. Again, this is intersection, so that means you have to be in both set. Who are in these 2 groups? Let's see, E, Ellen, and who else? F, Frank. I think those 2, that's it. So my final answer is A, complement intersection with B is equal to Ellen and Frank. So if you have something more slightly complicated, maybe it's easier if I just write out the first set and the second set separately and basically stare at them and see who they have in common. That's going to be the intersection. So who are these people? They didn't take 1A, but they took 1B. Okay, let's look at the next question. Here I'm going to have you try part D, E, and number 4. And then let's meet back after number 4. All right, next topic is to represent those sets more visual way. So if you're like a visual learner, maybe this will help. To visualize the intersection of the set, John Van in 1880 thought to use the overlapping circles. You've probably seen it as some memes and stuff. This illustration are now called Venn diagrams. To set up the Venn diagram, first we draw the universal set represented by a rectangle or box. So you notice the box here and then box there. Then we draw circles to represent set. So if I look at, and the overlapping area represents the intersection. I need more space. Intersection of the sets. So let's say when you have 2 sets, notice there's a box, that's the universal set. So I'm gonna, sometimes, I see a lot of times they don't even label the universal set, but if you have to label it, it's like U for universal set. I know it's confusing because there's a union and there's a universal set. I have 2 circles, so when you have 2 sets, set A and set B. So basically this circle represents set A and the second circle represents set B, and you see there's an overlapping part. So when you draw it, you're gonna make sure that there's an overlapping part. So this particular part happened to be A intersection B. So I'm gonna so maybe I should use red. This part right here, this is A intersection B. That's overlapping part. When you have 3 sets, things get slightly more complicated. Again, the box is a universal set, and you have set A, let's call it B, then let's call it C. So we have a lot of overlapping part. There's a part where A and B are overlapping, there's a part where B and C are overlapping, and there's part where A and C are overlapping. And there's like a part that everything overlaps. So if I want to look at the very middle part, this is A intersection B intersection C. It's overlapping everything. So if you have to take English 1A, 1B, and 1C, that the middle part is like basically people who took both, like all 3 classes. All right, let's look at some examples here. Let's look at number 5. Create Venn diagram to illustrate the following sets. Part A is A union with B, A union B. So first I'm gonna draw a universal set. Oh my god, that's not even a rectangle. A, B. Again, A union B is, you can be either in A, so this is A, people who took 1A. B is people who took 1B. Because it's union, either A or B, or even all A and B, they're all included. So everything that is shaded is included. So this is my final answer. This is A union B. So for union, whatever shaded is part of your final answer. Final answer. Let's look at part B, intersection. So there's A, there's a B. So again, A is this part, B is this part, but for intersection, you have to be in both sets. That means you have to be the overlapping part only. So that's my final answer. So on the exam and stuff, like when you have a Venn diagram question, it's hard for me to like know which one did you mean to have it as a final answer. So you want to kind of shade it even darker so that I know it's the final answer. So for intersection, only the overlapping part. So it has to be like shaded twice. It was shaded this part, it was shaded by A, and it was shaded by B. Okay, A complements. So here it's just one set, so I only have one circle. I still have the universal set, which is a rectangle. A complement is whatever is not in A. So A is what's inside. So A complement is not there. So it must be whatever is outside. So A complement is whatever is outside. The circle. Okay. All right, I'm gonna have you pause and look at figure out number 6 and number 7 yourself. It gets a little bit more complicated. Take your time, think you can do that, and we'll meet back at number 8. All right, number 8. I'm gonna make a problem. Write down the expression to represent the outline part, which is not there. So I'm gonna make it up right now. How about this one? This, but outside here. How can I write out the expression representing this part? So A, B. Notice that A and B is there. Everything is shaded outside, so something like complement, right? So if I look at the outline part, I notice that's just A union B, but instead of shading inside, I shade it outside. So if I have to find out the expression representing this area, or this Venn diagram, I'll say A union B, and then the whole thing complement. All right, so from the second one, more complicated one, I'm gonna have you try, see if we can try this one out. How about this one, and this one? Just part of B, but not in A, not in B. So here I'm gonna have you try yourself. All right, so let's look at the next part. The cardinality of set is just fancy name for number of elements in the set. It just means how many things are in there. So if I let's go back to the previous example here, like, oh, with the Bethany and Abe and number 3 with the requirements. So it's like, what's the cardinality of A union B? I have 1, 2, 3, 4, 5, 6 things in, or 6 people in it. So cardinality is 6. It just means how many people are in there. And for part B, A intersection B, for this example, cardinality is 2 because there are 2 people in it, right? So let's see. Go back to number 9. So on a Venn diagram, cardinality of set is to be separated into intersection part and the non-intersection part. Let's see what that means. So let's look at, out of 100 students are surveyed, so universal set has 100 people in it. 70, so here, 74 students completed 2 years of high school language requirement. 38 students took a second language at a language class at PCC. I think this comes from area 6 of the IGETC. And 15 students completed 2 years of high school language requirement, and, ooh, they say and. So this has got to be intersection. Took a language classes at PCC. So let's say this is set A, and this is set B. So A is the high school, B is the PCC. So there's A and B. So the last part is they took the high school language and they took a PCC also. So that's got to be A intersection with B, because intersection means like you did A and you did B. You're in both group. So that's got to be this part in the middle, the intersection part. And there are 15 students in it. So 15. So when I write 15 here, it only applies to this part of the Venn diagram, right? So this is where things get slightly tricky. It says 74 students completed 2 years. So I was gonna say 74 here, right? But then it becomes kind of weird because like A contains this whole thing, right? So if this is 74, this is 15, doesn't it sound like they have like 74 plus 15, 99 students? But A has only 74 students. So it'd be kind of misleading if I write just 74 here. So I shouldn't have done that. So like, what do I need to do? So basically there were 74 total people in A. The intersection has 15 people in it. So the rest of it is going to be 59. That's going to be in part A. So if I look at it now, A contains 59 part. That part that has 59, that part has 15. So when you add them all up, that's 60, 74. So this makes more sense. Same for part B. If I were to write 38 here, that's going to be a little weird because B is this whole thing. So it includes 15 and 38. So it seems like we have 15 plus 38, which is 53 people. I mean 53 people, but it only has 38. So that's misleading. So I don't want to do that. So I should have done is 38 minus 15. So that's 23. So I should write 23 here. So that's what I meant to say. We need to separate into intersection part and the non-intersection part. So this, if I kind of go back to part A, I mean set A, this 59 people, they took 2 years of high school, but they're not in B. So it means they didn't take at college, at PCC. All right, so how many students met the language requirement by completing 2 years high school, or highlight or circle or took a language at PCC? So basically it's the union that includes this part. So 59 plus 15 plus 23. So when you calculate it out, you're going to get 97. That means, because there are they surveyed 100 students. That means 3 people didn't take high school nor PCC. So 3 is outside. That's a complement of all of them. All right, let's look at the next question. More complicated questions here. I'm gonna have you like set up, and then I'll have you finish it. It's a little bit more complicated because there are 3 sets. So we have social science, we have humanities, and we have natural science. So here I'm gonna write out the cardinality here. They say 50 students are surveyed, so my universal set is 50. I think it's easiest, so this is a hint. I think it's easiest if you work from the very inside the intersection part, this part. This is where all 3 are intersecting. That means people are taking all 3 classes. So the last information says 3 were taking all 3. So yeah, that's 3. So let's say this is social science, humanities, and then natural science. Right, and then let's look at the next information here. 10 were taking humanity and natural science. So 10 are included in here. Again, I don't want to write 10 here because that's the intersection between humanity and natural science. So if I write 10, it sounds like there are 13 people, but they say 10 were taking that. So, okay, oops, I'm gonna change that. So, where is it not working? There. I'm gonna change to 7 because 10 minus 3 is equal to 7. So that's how we got this 7. So I'm gonna let you finish the rest of it, but you kind of have to work inside out and make sure that it says 10 were taking humanity and natural science. That means 10 is in this whole area. So I have to separate that into the intersection part and the non-intersection part. All right. Okay, so I'm gonna have you finish the rest of the worksheet.